Portology. Good afternoon. Hi, everyone. Hope you guys are having a great time so far and still awake. It's in the afternoon. My name is Chung. I'm a developer advocate at Google working on Android, actually working very closely with Tim. You guys just learned many things about building great-looking applications. And in this session, we're going to talk about creating applications that are flexible enough to be able to work across different hardware configurations and implementations and different locales out there. So we're going to be discussing some technical, best practices and techniques that, as developers, you can leverage to build your app such that they are flexible. And I guess the expectation is that this is an advanced topic, and I guess it would be helpful if you have done one or maybe a few Android apps, and you just learned about making your app looks good in the previous session, and now you want to make it, even better. And by the way, if you have any feedback and have access to Wi-Fi, use the link displayed up there to provide any feedback. We'd love to hear it from you. Okay, let's get started. I think you've seen this slide earlier, right? The point here is that we've seen a lot of momentum in the Android space in the previous few quarters, and we are very excited about it. We are seeing a lot of support from various players in the ecosystem, including, obviously, the developers like you guys, users, and the OEMs. Right? As illustrated on this slide here, starting on the upper left-hand corner, you have the Motorola a milestone device. It's got a great physical keyboard, big screen, and the right-hand side device, it's an X10 device, also a very great-looking device. Down below, we have, the Galaxy Tab 7-inch, really, really good-looking device, and I think you guys probably have seen that as well. And on the right-hand side, lower corner, you have Google TV, which was just launched a couple weeks ago, last week or a couple weeks ago. So the point here is that with these different form factors, large screens, small screens, physical keyboard, with trackball, without trackball, the thing is, with Android, right, and the various implementations out there, it appeals to people with different hardware preferences, right? Some like physical keyboards, some don't. And as developers, it's very, very important for you to understand the various techniques that are available for you to create your application to work across these multiple devices. And the good thing is that despite these different screen sizes and screen densities, what we found is that a lot of existing apps out there, even those apps that were published before, for example, the Galaxy Tab was available. These apps look fine on the Galaxy Tab. They work well on Galaxy Tab thanks to the Android platform. And we're going to look at some specifics on how it works. Okay. Let's have a look at how Android as a system handles resource loading. So for those of you that have built some apps, you probably are familiar with this directory structure in Eclipse. This is actually a screenshot from Eclipse. And it's got a bunch of directory. One of those is RES, R-E-S, which stands for resources. It includes things such as drawables. What we call drawable refers to the bitmaps, the pictures that you like to put on your application. Layouts, these layout XML files define the, how your application is presented to users. And Android does a pretty good job in separating out the presentation logic from the business logic, which makes it very, very easy for you to reiterate the layout if you want it without affecting the business logic. And if you've noticed on this screenshot, specifically drawable, you see a couple of funny identifiers next to it, drawable-HDPI, drawable-MDPI. So what do these identifier means? Well, through these qualifiers, these allow you to provide alternative resources for different configurations. What that means is that for different pictures that you put in these different folders that have the different suffixes, HDPI, MDPI, what happens is that at runtime, the system will determine, hey, what's my current configuration? And then it automatically picks the pictures that you have prepared from these respective directories and present to users. There's actually a bunch of qualifiers out there. There's about a dozen of them, 12 of them. And most notably, I'd like to share with you 4 that are related to today's topic, namely the screen size, the screen density, right? Because these define sort of the different form factors that are available out there, and screen orientation, right? You can, almost certain that your users would rotate their device while using your application, and SDK versions, and we're going to talk more about that today. You may ask, well, there are a lot of devices out there, right, with different screen sizes and density. How does the system actually match the different screen sizes, right? There are, for example, 3.8-inch, 4-inch screen, right? How does the system go about matching these different physical screen sizes with the identifiers that you've defined? I think it's best described using a diagram like this. It's a 3x3 matrix. As you can see, across the top, it defines the various buckets or categories of densities. So we are talking about low density, medium density, and high density. And the vertical axis, you have the different screen sizes, small, medium, large, right? Just like when you go to Starbucks, for example, when you order coffee, you order different sizes instead of the exact volume. How Android works is that, it sort of maps the different implementations out there to one of these buckets. For example, the G1 in the middle, it is actually a baseline model. It is considered a normal screen and medium density device. To the right of the G1, you have the Droid X, the Nexus 1s. These are considered normal screen device and high density devices. So through this mechanism, Android knows how to map these different device implementations out there to one of the 9 predefined buckets right here. And as I said earlier, if you look at the directory structure screenshot here, at runtime, the system would map the different layout, in this case, to the different actual hardware. So that screen size. Screen density works very similarly. If you look at the directory structure up there, drawable-high DPI, drawable-low DPI. So you just create the different graphics, right? If, for example, if you have a graphical icon that represents your company, you want to, put the icons into these different directories. So in terms of presenting drawables or these graphical elements on screen, I guess one of the goals of the system is to make sure these different graphics appear at approximately the same size across devices of different densities, as illustrated on the 3 diagrams here. So you have a low, sort of a 3 grids, right? The one on your left represents a low DPI screen, and the one to your right represents a higher density screens. And the system is trying to make sure, for example, if you want to put a logo, like the star. Let's say the star represents your company's logo. You want these stars to show up at approximately the same size across different devices. And if you look at the number of pixels involved in one of these stars or your company's logo, on the left-hand side, right, the number of pixels involved is fewer than those on the right-hand side, right? In order to retain the shape of the picture. And at runtime, the system is going to either scale the pictures up or down based on the availability of these graphics and the actual device that's being run on. And when it comes to the generation of these graphics, for example, when you're using your favorite photo editing software, Photoshop or GIMP or whatever, I guess the technique is that you always want to, first of all, identify the buckets, the different density buckets that you like to support, right? For example, you want to say support all 3. You always want to create the graphics with the highest density first, right? And then scale them down based on these principles. For example, if the width of the highest density graphics is 150, and then you want to scale it down by creating a smaller graphics with, the 100 pixel in width, because that's the difference that's represented by the 3-grid model. Well, so that's concept. Let's have a look at actual implementation. I drew this picture. Is it pretty? I'm proud of it. So this is an actual screenshot that I took from a G1 device. As you can recall, G1 device is classified as a medium screen size and medium density. So it looks okay, right? What if I just use the same graphic and then render it on a medium screen device and higher density device like the Nexus 1? You get something on the right. While it still works, the system does its magic to scale it up to the screen of higher density. You can see that the graphics on the right is blurred, right? Can you guys notice that difference? And then what if you want to optimize it, right? We always want to make sure our application look good, as we learned from the previous session, right? So you want to take the approach that I just described by introducing a higher density graphics in the HDPI folder of Drawable. And this is the result. And I don't know if you can tell from the projection, but I can noticeably see the difference in crispiness of the picture in the middle. And that's generated from on the same device, on the Nexus 1, but with an optimized assets. So we just learned that the system does actually a pretty good job in auto-scaling the different images for you, right? What if you are getting adventurous, right? What if you have actually identified ways that you think warrants the need for you to do the scaling itself, right? My advice for you is don't do it. Let the system do its job. The system knows to do it pretty well. And if you for example, if you insist on doing it, I would like to ask you to rethink. Ask your colleagues, the neighbors next to you, ask your boyfriends, girlfriends for their confirmation. Is this the right thing for you to do? The point being, the system is smart enough, and it knows how to do it for you pretty well. But let's say you want to do it, right? Here's the step involved. There are a couple parameters involved. If you look at the code snippets, when you want to render a bitmap, bitmap factory.options, right? It comes with the default options, and you want to override it. And the specific two parameters that you want to override are the in-density and the in-target density. What these parameters means is that the in-density is actually the density for the incoming drawable that you want to render. And the in-target density is the density of the actual device that the program is running on. So at runtime, normally the system is going to scale your pixels based on this formula in target density divided by in density. And if you want to disable that auto-scaling effect, right, you want to make sure that formula equates to 1. And the way to do it is to make sure those values match by manually setting the values to be identical for the 3 values you see on the last bullet. Okay, but again, I request you to rethink if you are kind of wondering about whether it makes sense for you to manually manipulate the pictures. Okay, we talked about screen sizes and densities. What about orientation, as I alluded to earlier in the session? So, as I mentioned earlier, the users will probably rotate the devices, right? You have the option of just letting the operating system handle the rotation for you, or you can disable it and decide to handle the rotation yourself. And keep in mind that there are different hardware implementations out there, right? There are, naturally landscape devices, there are naturally portrait devices, and there are some square devices. I guess the key point here is that when you are developing an application, don't always assume that, okay, it's going to be always be run on a milestone, for example, where users have the tendency of holding it upright or in a portrait mode. Be flexible to expect the possibility that they might have a natural tendency to use it in a landscape mode. For tablet, for example, right, the wider device 7-inch Samsung tablet, for example, I think the natural orientation is probably landscape, because a lot of people would like to use it to read e-books or whatever. And therefore, I guess the natural orientation could be landscape. And if you want to determine the natural orientation at runtime, you can use this code snippet, right? You can get a handle to the display object and read the orientation based on the get orientation API, and that particular API has been deprecated. And if you're running on Froyo or if you're targeting on Froyo, you want to use the get rotation API. Okay, let's talk a little bit about best practices involved with creating flexible UIs. So there are two screenshots up there. While the two applications are perfectly functional, they look a little bit odd. The one on the right looks a little bit odd, and the reason being those were generated using an absolute layout. And for those of you that may not be familiar with absolute layout, is that it's a method to lay out graphical elements on the UI. For example, you want to specify that I want to place the input box 5 pixels below the top and 20 pixels to the right of the left edge. And while this works on the screenshot on the left-hand side, which was produced from G1, which is a low-density device, and the screenshot on the right-hand side actually came from Nexus 1, which is a higher density device. As we learned from the star diagrams, the 3-star diagrams, the number of pixels involved, while the number of pixels involved to define the input box might be identical, it's narrower on higher density devices, right? So you can't reliably depend on absolute layout, and we advise you to kind of use another method, which is relative layout. It is basically a method to specify UI elements based on relative positioning with respect to other elements. So let's use this example. You would say, I want to put the input box to the right of the label, which is called input, just like that. And then the system would automatically put it to the right of it. And then you want to use something called DIP, density independent pixel, rather than absolute pixel. Because again, you want to avoid absolute pixels for the various reasons that I just mentioned before, and use this density independent pixel. What happens is that, remember the 3x3 matrix, right? So that defines the logical pixel units. And then once defined, the system would automatically scale that based on the actual hardware implementation that the app is deployed on. And as far as defining text size, you want to use something called SP instead of, again, absolute pixel to define the size of the text. Because what we've seen is that while the text size may look okay on one implementation, namely, for example, G1, it may look like a smaller font on a milestone, for example, just because, again, the differences in different screen densities. Okay, here's another observation that I've learned over the months. This is an actual screenshot that was taken from a Galaxy tab, which is defined as a large screen size and high density. And what happens is that if you have a legacy app, right? A legacy app probably has the target SDK version defined as something smaller than 4, like a cupcake, a 3 or something. And then, if you can recall, back in version 3, the different screen sizes were not introduced to the SDK. So the system would think, okay, this app is not capable of being rendered on a larger screen, so I'm going to put a border around it. This is something called what we call shoebox. And again, while it works functionally, it doesn't look good, right? It's not appealing to your users, and that's not to the best of your interests. And one quick way to sort of remedy this situation is to make sure that in your Android manifest, you have the support screens element properly declaring the support of large screens or medium screens or any density to true. That way, the system knows that, okay, this application is probably able to be rendered on a bigger screen, and it would stretch it to take the full size of the screen. All right, so we talked about the screen size and screen densities, the different form factors that you need to be aware of. What about the different versions out there, right? because as you probably can recall, we have rolled out a few versions out there over the years. And as illustrated in this picture here, right? This is a panoramic picture I took with my G1 several days ago. And as you can see, we have the various sculptures out there on the lawn. This is coming from the Mountain View headquarters. And traditionally, whenever the team launches a new version, they put up a new sculpture. So as you can see, the cupcakes, the donuts, and whatever over the years. So the expectation is that there will always be multiple versions out there in the market, and we're going to talk a little bit about how do you go about handling that in the future. And also one more thing, last Friday they put out a new sculpture out there, and that's not what I'm going to talk about today. I don't have more information there. Okay, so we talked with a lot of developers, right? A question that comes up over and over again is that, okay, you have multiple versions out there, which version should I target, right? This is our smart answer to it. It really depends. And then there's a number of reasons, right? There's a number of factors involved. And the two most important factors, I think, are the number of users and the number of recent features or the number of advanced features you want to implement. In this non-scientific graph that I drew, hand-drawn, you can probably see that the more advanced of a feature that you want to target, the fewer the number of users that it probably can benefit. And the reason being, it generally takes some time for users out there on the field to upgrade to newer versions for whatever reasons. And the question really is, you're going to ask yourself, okay, for the app that you are trying to develop, what's my feature set, right? You want to look at your feature set and then try to compare the various features that are available on the various versions of Android. For example, if you want to have a news widget kind of thing, that was introduced way back in 1.5, which means that the SDK version that you can use to target is probably you can go back all the way to 1.5, which will appeal to almost practically 100% of the devices out there. Versus if you want to target the data backup feature or live wallpaper features that are introduced in more recent versions, you're going to have to just balance that yourself to figure out, okay, what's my cost benefit? Additional features or relatively speaking fewer users. But over time you can sort of expect that users will be upgraded to newer versions, and newer devices that come out will be running newer versions. So here's another tool that helps us make that decision, like which version should I target. And by the way, this is publicly available on our websites, and it basically illustrates that over time, confirms the point that I just made. Over time, more and more devices will have newer versions, and if you look at this graph, anything with Eclair or 2.1 or more recent, we're talking about roughly 75% of devices out there, which is pretty great. Okay, so with the different versions out there, right? I mentioned that you can expect to see multiple versions out there, 2 to 3 versions or whatever. How do you go about creating an application that would work seamlessly across these different versions? So here's the thing that you want to figure out, right? With API changes. For example, you're developing on 2.2. Right, Froyo. You might be leveraging or using some APIs that might not be available on older versions. How do you make sure the backward compatibility of your application to maximize your reach? I guess the general recommendation is leverage Java reflection. Right? At runtime, you want to figure out, okay, on the current system that I'm running, is the particular class or is the particular method that I'm trying to use is available? And then you can provide a wrapper around that reflection logic, right? Whenever you want to access that information from your business logic, you want to poke the class and say, hey, is this class or is this method available at runtime? And if it is, use it. If not, you're going to have a backup plan. So here's the general strategy in theory, and let's have a look at some actual code. In this use case, I'm trying to use the getDensity method from the canvas class, as you can see, pointed to by the arrow, right? And this getDensity method specifically was introduced back in level 4, or donuts. What if I want to target cupcake devices that don't have this method available? So I would create this wrapper class called Canary with a static method. Method is just a Java reflection class that represents the method itself. And then you try to say, get me the method called getDensity. And if that getDensity method is found on the runtime, it'll return a reference to that method. And that reference, based on this code snippet, is stored in getDensity reference handle. If it's not found, an exception will be thrown, and you're going to have to do something differently. So that's the wrapper method. And let's have a look at how this method should be used. We're talking about the same class, same wrapper class. And whenever you need to access the getDensity, you want to do something like this. You want to check for the reference, right? If the method was successfully identified, it's going to be available in the getDensity reference or handle. If it's found, then invoke it. If it's not found in the else clause, you might want to do something different by having, in this particular instance, having a default variable or something so that your application won't crash, which is a great thing for users from a user experience standpoint. So there was new method, right? What about you're using a class that might not be familiar? I mean, that might not be available in the previous version of Android. Very, very similar approach is used here. You, again, create a wrapper class, right? In the wrapper class, within the static block, you want to try to load that class, in this case called event-log, which was introduced in Froyo. It's something used to read diagnostic information at the system level. You want to try to load this using the forName method. Okay, if it's found, everything is good. If it's not found, an exception will be thrown. And then there's this check available. Oops. There's this check available method, which is a static method, empty method, and the idea is that a caller can call this check available. And since it's static, it would invoke the execution of the static block above it to check the forName and so on and so forth. Okay, and the third method in this wrapper is the write event, which is nothing but a wrapper for the actual class that you are trying to invoke. And then here's the actual usage of the wrapper class. For example, in this my activity, you want to use it, so you would do a event log wrapper dot check available. As you can recall, this is the static method that is used to trigger the invocation of the static block, which calls forName. Right? If forName works well, everything is good, right? And then you want to set the Boolean to true. The Boolean is called API available. Set it to true, indicating that yes, the class is available. Otherwise, if the exception is thrown, which implies that the class is not available, then you would set that Boolean to false. So when you're actually trying to use this class, you would just check for the, the Boolean value. If it's true, then it means that the class is available. Then use it. If not, do something differently. So this is one of the ways developers can use to make sure they have maximum compatibility across different versions. But I would say, while this is a good method, it may not work for all features. For example, account manager, which is more involved than just making API calls, that's something that makes it very, very hard to use a strategy like this to maximize the compatibility. But for the most part, you can leverage what we just described to kind of make sure your application is version proof, sort of. Okay, we talked about version compatibility. Let's move on to localization, right? We are talking about an international audience here. You have pretty much have access to sell your application through Android market to the rest of the other countries that support Android market. So let's have a quick look at localization here. Here's a quick code snippet to show a button. You want to render a button on the screen and put a text on it. Voila. Right? It works perfectly fine. But can this be improved? We all as programmers are lazy, right? We have the tendency to just hard code the labels. And while it works, again, it may not be that flexible in the event that you want to localize your application to, say, English-speaking countries or Spanish-speaking audience. So to do that, it's really simple. For those experienced programmers out there, you guys should be all familiar with the resource bundles concept. Same idea is applicable here. In the values folder of your project, you just have to create different values folders, prefix or suffixed rather, by different languages and regions. For example, -ES, -PT, region, Brazil, for example. Within the strings.xml files, which we'll see later, it shows you how you can put different languages into the different bundles. So this is the setup. So how does it work at runtime? At runtime, the system would sort of go through this logic, the 4 bullet points out there. What is my current system locale, right? It could be Portuguese or something else, right? English or whatever. And the thing is, it's got a default version, default locale. And at runtime, it would query the app package, the APK file, to say, hey, if this developer has paid attention in Fretstock and created the different folders with the different localized strings. And if they did, and if it's able to find the corresponding folder that matches the current locale, then it would use it. If it's not found, it falls back to the default, the values one without any suffixes. Okay, here's an actual example. Formatting string. You want to put a label and a text, right? This is an application that tries to figure out the number of engineers needed to change the light bulb. And in the different strings, in the different localized strings resource files that I mentioned, you just put in the contents, the localized contents. The first version, is Portuguese. I hope that's right. That's based on Google Translate output. And and the second strings.xml contains the strings, in the other language, in English in this case. Going back to the code snippets, this is how you would instantiate this string by calling, getResources.getString by referring to the r.string.question, which automatically maps to one of these, depending on, again, the current system locale. And as you can see, you can also merge data at runtime. You can, merge an integer value to the string that to be displayed on the UI. Okay, we talked about localization. How about from an Android market standpoint, right? Once you've developed your app, you've tested your app, you want to distribute it. Android market plays a very important role. It's sort of a matchmaking role between apps and devices. On one hand, you have a bunch of developers creating great apps, publishing apps. And on the other hand, you have a bunch of devices checking in. Hey, get me some apps, get me some apps. And whenever these devices check in, they report their device hardware capabilities. And different hardware versions or different hardware models, as we talked about, have different capabilities. Some have cameras, some don't, so on and so forth. And let's see, what sort of mechanism Android market has to make sure actually the intended audience gets access to your application. The worst thing that could happen is that if your application requires camera, and what if the device doesn't have a camera? That would be a bad user experience. So there are two sides. On the application publishing side, through Android Manifest, you can create, roughly 6 different filters, right? And I'm just calling out 4 ones that are relevant to this talk: users, features, users, configurations. And these tags actually tells the system, hey, my app actually will require telephony features, or it does require OpenGL. Or in the case of users configuration, it says, okay, my app requires a physical keyboard for whatever reason. Or users SDK, my app requires a minimum version of SDK, be it Froyo or Cupcake or whatever. And then you can also define things such as support screen. What kind of screen sizes can my app support? So through these different queues, Android market knows, okay, here are the app's capabilities or requirements. And then these are created through Android manifest. But through other methods, you can also specify, okay, here's the geographical location I want to target. Here's the carrier restrictions for making my apps available. And native platform, if your application uses NDK, which we saw in Tim's talk, NDKs targets to specific hardware, and then these are kind of filtering criteria you can specify. And you can have a look at this URL to understand the full definition of these different criteria. And also, so we talked about app publishing aspect of it. A US developer can say, okay, here are the requirements for my app. But for those devices that are checking in, how do we make sure those devices conform to a certain standard? And that's done through Android compatibility definition, right? If you go to the URL, you can find that this definition defines things such as the minimum requirements an Android compatible device must have, for example, touch screens, USB slots, so on and so forth. It defines sort of the minimum requirements to be compatible with Android, and to ensure that these devices that are checking into Android market actually conform to a certain standard, so apps won't break. And from an OEM standpoint, they would have to make sure that they run through the CTS, compatibility test suites, to make sure they are compatible. Okay, so that's kind of completes the whole cycles from app publishing to devices checking in, how Android markets make sure your apps are only visible to the intended audience. Okay, I guess that wraps up my talk. And to summarize, I want to say that it's actually pretty straightforward to make sure your app could be compatible to various devices out there with different hardware configurations and versions. And I strongly encourage you to have a look at our online documentation for the information that we just discussed. Thank you very much. Obrigado.